I'm going to show you in this podcast that an array is a pointer. More specifically, that the name of an array is the address of the first element in this array. In this program, I have an array of 3 integers that I initialize with the values 15, 16, and 17. If I take only the name of the array, r, like this, well, it will be the address of the first element. I can print this to show you. Let's print it with %p because it's a pointer, it's an address. So here, if I print r, the name of the array, we're using %p, I will have the address of the first cell. Let's compile and execute. You can see in the memory that we have the array created, and the first element 0 starts at the address FFF4. So when I print, we're using %p, the name of the array, ARR, well, it prints FFF4, which is indeed the first element of the array. All right, let's get this address in a variable. So int star ptr for pointer. And what I will put in this variable is r, which is the name of the array. And indeed, we get the address of the array, which is the address of the first element. I put it in a pointer, ptr, which is of type int star. So it's indeed an address, and at this address you have an integer, which is the value of the first element of the array. And I can use pointer ptr to do pointer arithmetic. So first I will use this pointer as I used to, using dereferencing. So what is pointed by ptr? Let's put the value 2, and let's see what's happening here. I compile and execute. First I create the array, then I create the pointer. So it's the value FFF4, which is the address of the array, which is the address of the first element, array of 0. And what is pointed by ptr? So what is at the address FFF4? Let's put the value 2. So it is indeed modifying the first cell, the first element of the array, by putting the value 2 instead of 15. So you see that I can use the array as a pointer. So it's exactly the same if instead of using this pointer, I use the array. What is pointed by the array equals 2 does the same thing. Because here, if I execute step by step, indeed, what is pointed by the address of the array is the first element, and I will put 2. Now, let's go back to the pointer here. So this modifies the first element. What if I want to modify the second element? That's how you use pointer arithmetic. And let me show you how to do that. Well, here, I will write something in parentheses and say that I want to modify what is pointed by, and let's put everything that we want in these parentheses. And this is indeed important, and you will understand why. And here, I want to say what is pointed by the second element of the array. So it's pointer plus 1. How does that work? Well, here we have the address of the first element, and we add 1. So if we add 1, we go to the second element of the array. Let's put the value 3, for example. Let's try to compile and execute to see what's happening. So first, star ptr is what is pointed by the address FFF4. So it's the first element, and we put 2. And now, what is pointed by, and the parenthesis is very important here, by ptr plus 1. So it's FFF4 plus 1. But what does it mean plus 1 when you add 1 to an address? Well, here it's FFF4 plus 4 bytes, because it's the size of one element of the array. And indeed, we see that the pointer here is of type int star. And because of int, we know that we have to add 4 bytes, which is the size of one int, one integer. So when we have +1, when we add +1 to a pointer, we don't do the original arithmetic. We do the pointer arithmetic. And the pointer arithmetic will calculate like this. First, we take the address, FFF4, and then we add this, we had 1 multiplied by the size of what is pointed by PTR. So 1 multiplied by the size of an integer. And the size of an integer is indeed 4 bytes. So we will add 4 bytes to FFF4, and it goes to FFF8. If you look closely, it's the beginning of the second element. And indeed, here we modify the second element. So if you understood what's happening here, if I want to modify the third element, I will use the same principle. PTR plus 2. And let's put the value 5, for example. And the same goes on here. Here, FFF4 is the first element. FFF4 plus 1 multiplied by size of int is FFF8, the second element. And FFF4 plus 2 multiplied by size of int, which is 4. So 2 multiplied by 4 is 8. So we start at FFF4 and we go 8 bytes to the right and we go to FFFC, and that's the beginning of the third element. And that's indeed the third element that we will modify here using this pointer arithmetic. So that's quite interesting, and it means that here the equivalent will be what is pointed by the array, or also array of 0. Here, the equivalence is what is pointed by array plus 1. It's the same as for the pointer, or also array of 1. And here, what is pointed by array plus 2 is the equivalent of array of 2, the third element. And that's it. So you know how to use pointer arithmetic to navigate through an array. So now, what is happening if I forget those parentheses? Well, let's try. If I write something like star PTR plus, let's say plus 1 equals 3. So what does it mean? First, we will do the dereferencing of PTR without doing plus 1. So we do the dereferencing and we go to a location in memory. And then when we are at this location, we say plus 1, and it doesn't mean anything. When you are at a certain location and you do plus 1, it doesn't mean anything. And then after that, you assign 3. So even more, it doesn't mean anything, this line here. So when I hit the compile button, it should get an error or something. And indeed, when I hit compile, I get an error. Expression is not assignable. Indeed, this expression here, we cannot assign the value 3 because this expression doesn't mean anything. So that's why when you use pointer dereferencing and when you use pointer arithmetic, you should be very careful where to put the parentheses here. First, you want to do the arithmetic within parentheses, and then you use parentheses and do the dereferencing. Always in that order. If you do first the dereferencing and then do a sort of arithmetic, it doesn't do anything. It doesn't mean anything. So be careful. Well, I invite you to try by yourself. Put some code here and try to modify some of the values of the array using pointer arithmetic. And it's your turn now. Try it.